Hi, so I'm redoing for pre-calc section 3.6 because LT Lin Tran class of what would it be 2018 told me that there was no audio on my YouTube lesson that was posted. Can you believe it? About 6 or 7 years ago. So I feel pretty badly that that happened, and it's amazing that for 7 years nobody ever told me that. But anyway, I've got two pictures here. I'm not showing this picture on the right hand side because I'm stalking any girls or anything like that, but just to let you know that the girl in the center there, that's this girl here in the center, was my student Victoria Pham, circa 2008. She was in my pre-calc class, and I think this was a picture when she was crowned Miss Vietnam America. But that's not the point. This topic is really on modeling, and your best friend for modeling is this, not the runway. Okay, so I'm going to be teaching you how to do modeling using the graphing calculator. Okay, so in order to do that, you're going to need your graphing calculator. And what I have here to start out with is an example, a data set. So you need to put that in your calculator. So let me bring my calculator up. Slowly but surely it'll get up there. Okay, you turn it on. And I'm going to clear everything. And then I'm going to enter the data. So you're going to go Stat, which is this button here. You're going to go Edit. And I already have things in there. Do I have the exact data set? Wow, that's exactly what I have. So it must be a leftover from when I was lecturing 3.6 in the year 2016. 2016. So what we have is you enter the data set. You know what? I'm going to clear this and kind of walk you through the whole step so that you know what needs to be done. So don't delete the list, okay, because then you can't recover. So you go clear, and then you move down arrow, and it clears it. And so to enter the data, you're going to go 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, 7, and 8. 6, 7, and 8. And then you're going to enter the y value. So that's a 3, a 5.2, a 7, and 9.1, and 11, 12.9, and then 15, and then 17. Okay, so you've entered the data in your lists, okay, and what's the next step we do? We first of all turn statsplot on to get a scatter plot. Okay, a scatter plot. So you're going to go, all of the instructions there. Okay, it says turn it on. You're going to go second stat plot, which is the y equals, and mine is already on. So sometimes, okay, if you go select that, you turn it off and on like that. So that's off, and you turn it on like that. And then if you go graph, let me make sure that there's nothing in y equals. Okay, because all I want is a scatter plot, and so it draws the XY values like a scatter. It doesn't join them, doesn't join the dots with a line or anything like that, but it just does the points itself and scatters them. Okay, so that's how you turn on scatter plot, and that's how you see things. Okay, and what we really want to do is we want to do what's called a regression fit. So I'm going to go kind of snip this out and explain what that means. So here's this data, and I want to fit some kind of function or some kind of curve to it, okay? And right now, the way it looks is that, hey, a straight line is a great fit, great fit. But sometimes it's not a straight line. Sometimes it could be, not with this data set, but with some other data sets, it could be like an exponential data set, okay, something like that. Or it could be a quadratic of some sort, okay? It could be a quadratic of some sort, going like that, okay? So your calculator is very powerful, and it lets you do all that. The only problem is that, you know, how do you decide which is the best fit? You've got various curves, and you know the curves might look you know, like if you've got a situation like this, okay, well, is my exponential graph a better fit to this, or is my quadratic graph a better fit to this? How do I decide? How do I decide? So there's something called R squared in statistics. It's called the correlation coefficient, okay? And your calculator also calculates that. Calculator calculates. This number is always less than or equal to 1. I mean, it's highly improbable that it'd be exactly equal to 1. But first of all, it's always positive and it's near 1. So the closer the number, this number is to 1, the better the fit. The better the fit. Okay? And so let's go see how your calculator does that. So before your calculator actually can do it and display it, you need to go to what's called diagnostics. So the way I've got it is you go second, catalog, which is the 0 button. You're going to go diagnostics, which is the letter D. Okay, you'll scroll down and you will turn it on. So that's diagnostic on, enter, enter. And once it's done, it means that now when you do any statistical calculations on the data set, it's going to print out an R squared as well. So we're first going to try a linear regression for the data. So turn it on, okay, and you're going to go stat, you're going to go calc. So my calculator is an older version. Some of the newer versions have a much better way of entering the data. It's much more obvious as to what needs to be done. This one's kind of old school, so I'm going to teach you what I have. So it tells you what equation it's going to use. Okay, it's going to use ax plus b. The reason is because there's another linearage here which they call a plus bx. And for the life of me, I don't know why they have two different ones, but I've talked about this in class. It seems like a pretty silly thing to do, so I'm just going to go for number 4. Okay, and at this point, you need to tell them where is your data. Well, your data is in L1, comma. The other data set is in L2, comma. And do you want to save this data, the regression equation that you have, into a y value? Then you're going to go vars, yvars, function y1. Okay, if you want to put it in y1. You can obviously put it in y2, y3, all the way to y9. And then you're going to hit enter. So it does all the magic for you. Okay, and it computes the a, which is the slope of that line. It computes the b, which is the intercept, and it computes the r squared. So as you can see, okay, as you can see, this is a straight line is a very good fit because this number is so close to 1. So your regression equation becomes 1.9833, rounding to 4 decimal places, plus 1.1. You should really put zeros there, okay, even though it's not in there, just to kind of force the habit that we are going 4 decimal places. Okay. So we got a regression equation, and now what I'm going to do is I'm going to graph the regression equation as well and show you how the data really fits. So now if you go look at y1, you'll see the data is automatically put in there. Okay, 1.983333x plus 1.1000. And you go graph that, and you'll see what's called the line of best fit, or the curve of best fit. So it's not surprising that this is a linear regression because the data was generated by using a linear equation. So that's not a brainer. Okay, it's a no-brainer. Okay, so that's how you do regression with linear regression. And instead of linear, if you want ln or the log regression, okay, what the book calls the logarithmic regression, we can do that too. And so we go second, and we're going to go stat, we're going to go calc, and we're going to look for linear regression, ln, not linear, ln reg. Okay, and so we're going to do 9. We're going to put the lists that we are using, L1, comma L2. Where you go, L2, comma, and now we're going to put it in Y2. Okay, so we can compare the two graphs. Function, and I'm going to put it in Y2. Enter. And you can see now that the R squared is like 0.9207 compared to 0.99 something. So this is obviously not going to be a better fit, and let's see it visually how that looks. Okay. So that's my linear, and here's my logarithmic. Okay, so you can see that it's not hugging the data points as well as the linear equation is. So obviously the linear regression is not a very good fit, and you can tell that from R squared. Okay. So the way I want you to really organize your data or your work really is, I'm going to go back. I'm going to kind of snip this out here. Okay. I'm going to just, well, actually, I'll just do that. So we're going to do multiple regressions on a given data set. So the best way of organizing this would be in a table. So what I want you to do is something like this: model type, model equation, the A value. Why is this? I don't know why it doesn't go further. Okay, model equation, the A value, the B value, and the C value, and the R squared value. And we'll make a table of this. Okay, because then it's easy to see and pick out which is the best fit. So first one was linear reg, L-I-N-L-E reg. So y equals ax plus b. And what were the numbers for a and b? What did we have? We have 1 point. No, that's ln reg. Linear reg. What did we get? Do I show the data in there? I didn't show the data in there. Okay, let's go back, and we're gonna go stat. We're gonna go calc. Oops, not that. Stat, calc. We're gonna look for linreg, which is number 4. And if you don't put in L1 and L2, it assumes that the data is in L1 and L2, and it won't generate an equation. Put it anywhere. It'll just give you the coefficients and the correlation constant. So there it is. Okay. So our table would have been. Let me see if I can kind of move this out. Can I move this out? I can't move it out. So what was it? 1.9833. 1.9833. That was A. B was 1.1000. There is no C value in here. The C comes in for some of the other regression types. Okay, and the R squared value was 0.9997. Okay, and then we had ln reg. So the next one was ln reg, and then its equation is going to be y equals, and it tells you what the equation is right there: a plus b ln x, and a is 1.2389, b is 6.6281. there is no c, and r squared is 0.9207. So if you've done 2 regressions and you want to pick one, well, you're going to pick one with the highest r squared, which is this one here, 0.9997. Okay, and then you'd highlight the model and the variables in there and the equation in there. Okay, so that's how you organize your work for the regression stuff. Okay, do I have another problem in here? What is r squared? So we kind of did that. We did that. Now we are going to use another data set, and we're going to do all 4 of these regressions: exponential, linreg, quadreg, lnreg, and then we'll try and organize it in the table that we had. Okay, so let's see if I can get this done in the next 15 minutes. Come on, calculator. Let's go clear that. And we're going to go stat. We're going to go in L1, and fortunately L1's okay. 1, 2, 3, 4, 5, 6, 7, 8, and L2 is 1.5. Enter. 7.4. Enter. 10.2. Enter. 13.4. 15.8. 16.3. Oops. Yeah, you screw up on one data and then you're toast. Okay. So really the habit to get into is to check before you go do any more work. 18.2 and then 18.8. Okay. So let's make sure we've got the data right. Let's go up there. We've got 1.5, 7.4, 10.2, 13.4, 15.8, 16.3, 18.2, and 18.3. Okay, so the first regression they want you to do is exp reg. Okay, so you're going to go stat, calc, and you're going to scroll down until you see exp reg, and exp reg, And like I told you, if you don't specify L1, L2, then it automatically assumes. But I want this, the regression equations to go into particular variables. So I'm going to go second L1, comma, second L2, comma, and then I'm going to put it in Y1. Okay, so now we're going to organize the table. Okay, we're going to organize the table in here. These are the four that we want. And so, if you remember, it was the model type, model equation, A, B, C, and R squared, and kind of make a table so it looks like a table. Okay, and model type is exp reg. Okay, and you get a y equals a times b to the x. A is 2.9219 and b is 1.3241 and c is not needed, and r squared is 0.6701. So if I go into the calculator, you should see that my equation is in Y1. Okay, there it is. Okay, all right. And so then the next step I want to do is do linreg. So I'm going to go stat calc linreg, which is number 4. I'm going to go L1, comma L. Comma second L2, comma, and I want to put it in Y2. And so our equation would be linreg. So this will be linreg y equals ax plus b, and the coefficients are 2.8, 2.28, 2.289, whatever, 93, and then b is 2.3357, 2.3357. There is no c, and the r squared value is 0.900, whatever, 006. Okay, and then so I expect you to really do these other two, organize it in this table, and then pick the one that you think is the best fit by looking at the r squared values. Pick the highest r squared value. Okay, this guy should have been 0.9006. Okay, and so that's how you organize this work, and that's how you do the modeling using a graphing calculator. Unfortunately, not on the runway. Right. What else do I have after this? And so my conclusion is that ln is the best fit, and you can see that the r squared is 0.9935. Okay, much bigger than what we have for exp and for linreg. All right, so that's 3.6. I want to give a shout out to Lin Tran for pointing this out. Hopefully this is recorded well and I can upload it to YouTube. Keep your fingers crossed. I'm going to keep my fingers and my legs and my brain crossed.